Hey guys, so we are going to be thinking here about subtracting with regrouping. So now you're confident, right, with adding and subtracting fractions and finding the common denominators before you do that. And what you're going to find here is there's going to be some instances where you're forced to regroup. And you actually are already familiar with this with whole numbers. So say you have something, I don't know, you have 27 and you want to take away 9, right? And if you're not just kind of using logic, you're using the traditional algorithm, this is when regrouping would come into play. So you would say, okay, I know I start with my ones and I say 7 minus 9. And you go, oh, I can't do that without going into negative land. So you knock on your neighbor's door up here, right? And you look to your tens and you say, hey, tens, can I borrow one? And they say, oh, yeah, sure, have a 10, leaving 110 in the tens column. Well, now you have 17 minus 9, right? You have more that you're starting with, and you can take just some away. And that's exactly what we're going to play with here, but now with fractions. So let's say we have something, we've got 2, and let's say, I don't know, 1/3, and we're going to take away 1 and 7/9. So I'm just stacking it here. You can also write it in sort of the side-to-side orientation. But here we have right? We're going to look to our mixed numbers. We're going to, or sorry, our whole numbers and our fractions. First, we want to subtract the fractions. So in order to subtract, what we know is we need to find a common denominator. These don't have one currently. So if I count by threes and I count by nines, 3, 6, 9, I know that I'm going to end up with 9 as my common denominator. Well, what diva did you use to get that? 3 times 3 got us 9. So our diva is essentially 3. Okay, so 3. So now we have 1/3 has turned into 3/9. Okay, and 7/9. Well, 7/9 didn't change, right? We essentially used the identity property. Our diva was 1/1, so we still have 7/9. That kept the same look. So now what we're going to do is we're going to subtract, and we go top to bottom, just like we did over here. 27 minus 9, and we run into a very similar predicament. 3 minus 7. Ooh, I can't do it without going into negative land. And we don't want to be there right now. So what we can do is we can rely on our neighbors. So we'll say, hey, neighbor, can I borrow from you? And this 2 says, oh, yeah, sure thing. But what's a little bit different is since we're working with fractions, we just need to think about what our wholes are made up of. So in this case, our denominator over here are ninths, right? So one whole is going to have 9/9. Another whole will also have 9/9. So we essentially have, and we could think of it like putting our little 1 bar around it if we want, reminding us that these are 2 wholes. That's representing this right here. So we're going to just borrow one of those, right? So we're going to just take it over. We're going to move it on over and say this 9/9 is going to move right over here. Okay, and we're going to add it on to our 3/9. 9/9. Okay, so this has moved right over there, leaving us with 1, right? 1 whole left here. So this is now 1 whole. Okay, so now we say, okay, I have 1 whole. This has changed looks into 3, 1 and 3/9 plus 9/9. Okay, so now we have 1 whole and 9, 10, 11, 12 ninths. So we've created an improper fraction. 1 and 7/9 hasn't changed, so I'm just going to bring that over here. 1 and 7/9. Cool. Well, now our numerator is bigger than our top numerator is bigger than our second, numerator. So now we can just subtract normal. So 12 minus 7, 7, 8, 9, 10, 11, 12 is 5/9. You want to start with your fractions first and then move into your wholes. 1 minus 1 is 0. So we simply end up with 5/9 using regrouping to help.